Yes, good afternoon to all the students. One student, please confirm the screen is visible to you with the slide. Single phase parallel inverter. We start the class, today's class. Right. So, anyone, please confirm the screen is visible or not. Right. So, in unit 4, yes, very good afternoon to everyone. Right. So today's class we discuss regarding the single phase parallel inverter. If you move into the industry side, people ask you how many types of inverters are present. So you should mention pure sine wave inverter or sine wave inverter, modified sine wave inverter and square wave inverter. So once again I repeat this one. Three types of inverters are present practically. One is sine wave inverter, modified sine wave inverter, and next one is square wave inverter. So what is sine wave inverter? Sine wave inverter is the series inverter circuit. Parallel inverter is the square wave inverter. So what is the use of the parallel inverter? Parallel inverter we are using in the electronic applications. Parallel inverter is never used to turn on any bulb. So parallel inverter generates the square waveform which is in the form of AC. Whereas the bridge inverter, which we have studied, which bridge inverter is used to generate the modified sine wave. Modified sine wave, 90% is approximately equal to the sine wave, and which is also used to turn on the bulb and the motor. So modified sine, how many types of inverters we are having? Sine wave, modified sine wave, and next one is square waveform, square wave inverters. So other names are nothing but sine wave inverter means series inverter circuit, square wave inverter means parallel inverter circuit, and modified sine wave means bridge inverter circuit. So we have already done this series inverter and the bridge inverter circuit. Okay. So once again, yeah, right. Today's class we concentrate on the parallel inverter, which is used in the electronic communication applications. This particular parallel inverter. So very first thing, you should remember this circuit. Let us see the complete circuit diagram here. And in the entire subject, we have to see how the current flows, what are the case 1, case 2, or mode 1 and mode 2, which we are studying throughout the subject. Now we do start the explanation. So why the circuit is like this? What exactly the meaning here? So the parallel inverter contains the center tapped transformer. So you can ask, sir, I will use the inductors. Why we have to go for the center tapped transformer? So in few circuits where the energy storage is maximum, so we must go for the very large values of inductors. So here we are going for the center tapped transformer for maximum energy transfer from one circuit to another circuit. So where inductors cannot work with high efficiency and high power transfer, we go for the center tapped transformer. Okay, now. So parallel inverter first electrical component is center tapped transformer. So at this two windings, center tapped transformer has got the high level winding and low level winding. So in the sense we can say the primary and secondary both are connected to the single phase. Right. So this is the circuit of the center tapped transformer. The tapping point is taken at the common point. Right. So now one simple question. Can we apply DC supply to the transformer? Any one student? My simple question, this is the inverter. We are using the center tapped transformer, whether it is center tapped or ordinary normal power transformer. Can we apply the DC supply to the transformer? Anyone, any student? Can we apply a DC supply to the transformer? The answer, we cannot apply directly the DC supply to the transformer. But with the help of the switches, remember this is the most important question. With the help of electronic or power electronic switches, by turning on and off the switches, a DC supply can be converted into pulsated DC, and pulsated DC can be applied to the transformer. So switchable DC or pulse signal. So I repeat once again, a direct DC supply cannot be applied to the transformer or center taper transformer, but the DC supply with the combination of electronic switches or power electronic switches such as the SCRs, when they are turned on and off, one is on, another one is off. In that sequential manner, the pure DC can be converted into the pulsated DC, and then that DC supply is applied to the, that is pulsated DC or switchable DC is applied to the transformer. Okay. So why we are using the inductor? The question is this one. So without the inductor also current starts to flow through the SCR. Why especially shown the inductor? So inductor passes the pure DC current. Inductor acts as a short circuit to DC current. So if in the supply, if you are having any harmonics or unwanted AC components or else any AC current is present, if the supply is not pure, then this inductor will filter out that particular AC components. It will stop the AC component. It will pass only the pure DC. So this is the reason, one of the reason, if the supply is not a pure DC. So you should remember why we are placing an inductor in series with this supply. Inductor in any circuit, when it is placed in series with the DC source, inductor filter out the AC components and passes only the pure DC components if the supply is not pure DC. Okay, right. So now why we are placing the capacitor? Everybody know capacitor here. Capacitor, when it charges and discharges only, we are able to convert this pure DC to the pulsated or switchable DC in the form of the square signal or pulse signal. Okay. So now let us see the operation of this circuit. Parallel inverter is very important circuit. The entire subject: bridge inverter, series inverter, and parallel inverter. Okay, right. So now we just move to the mode 1. So what is the mode 1? When the firing pulse is given to the SCR T1. Supply is on and firing pulse is given to the SCR T1. We are supposed to pass which current to the load? AC current. Current should flow in one direction and then current should flow in opposite direction. Right. So we see the mode 1. What is the mode 1 now? So when the supply is on with only SCR T1 is turned on with the firing pulse, the direction of the current starts from the positive terminal of the source and then it moves to the inductor. So you make a note now only. So VS plus to inductor, inductor to SCR T1. You can see in the animation T1 is on now, and from the T1 to the center tap transformer, one end of the winding. Okay, so it flows through the center tap transformer, one end of the winding, and then it flows through the common point. Energy travels from high value to low value, so it flows through the common point. Now here, before starting the entire circuit explanation, the capacitor is completely charged to the voltage. That means we assume that capacitor is initially charged. To what voltage it will be charged? Let us say I am applying 5 volts here, but the capacitor is connected in parallel with both the windings. Okay, it is connected to both the windings. Therefore, if the supply is 5 volts across V1 and 5 volts across this lower winding, upper winding and lower winding. So overall, how much voltage will be there? 10 volts. So that's why here the capacitor nature, it charges twice the source voltage because of these two upper and as well as the lower windings. This is the advantage of the center tap. So why we are not using the inductor here? So I want to charge the capacitor to the maximum value, double the rated value. So it is possible only with this center tap transformer. So again, in the mode 1, when the supply is on, right, when the supply is on, direction of current start from Vs plus to inductor, and inductor to the T1 is turned on already. From T1 to the upper winding you can write here, you will write here U1 and U2. Okay, U1, and from U1 to the common point, this red point is called the common point. You can put it as the 0, O, point O, and from point O to it comes back to the Vs minus. You can see the direction of the current now. So already we have discussed, if capacitor is not there, we cannot achieve the pulsated signal here. Therefore, current flows through the SCR. Now we see the current direction also. You can see, every student can see direction of the current under mode 1 when the supply is on, when the T1 is on. Direction of current start from Vs plus to inductor, inductor to SCR, and from SCR to the upper winding U1, and then from U1 to common point to the Vs minus. Current always travels from high energy level to low energy level. During this process, okay, this is the mode 1, and capacitor is already charged to the twice the source voltage, you can see here with the polarity. Now, during this process, you can see mutual induction process takes place between upper winding and secondary winding of the transformer. You can see here the animation. You can see during this process, mode 1, mutual induction process takes place between upper winding and the secondary winding. Therefore, due to the mutual induction process, according to Faraday's law of electromagnetic induction, voltage induces in the secondary winding because of the upper winding voltage, and hence current flows through the load. Now the current is flowing through the load in this direction. Yes, sir? So now current is flowing in one direction through the load. So what is the mode 1? Mode 1 is firing pulse is given to only T1. T1 is on. When the supply is on, direction of the current start from Vs plus to inductor, inductor to T1, inductor to T1 to upper winding U1, U1 to common point O, and from common point to the Vs minus. Common point or center tapped point O. Okay. So during this process, due to mutual induction principle, the voltage induced across the upper winding links or induces with the secondary winding voltage, and hence the current flows through the load. You can see here V0 is equal to Vs because only upper winding is inducing with the secondary winding, not the both the windings. Okay. Now we move to the second part, mode 2 we see. Okay. Our capacitor is already charged in this condition. Okay. Now you see all of it. This is still the mode 1. Due to mutual induction, voltage is induced with the secondary winding. Current flows through the secondary winding. Okay. So now we just see what happens to the circuit. Now you see the waveforms here. So IG1, we are giving the pulse signal. You must draw the pulse signal here. The IG1 means the gate current of the SCR1. IG1 here you must draw the pulse signal. IG2 is not given pulse signal. And capacitor voltage is how much? Capacitor is charged to 2 times of the source voltage. You will see it. These waveforms are important for this topic. As the capacitor, yes, you can see capacitor is charged to the 2 times of the voltage. When SCR is on, what is the voltage across the SCR? 0. When SCR is on, it is just like a copper wire. Therefore, its voltage, internal voltage is 0. So these 3 waveforms you can show in the examination, but still off waveforms you are going to show. Forget about IT1, and output voltage is equal to the source voltage. Let us move on to the mode 2. Okay. When we complete the mode 1 and mode 2, you'll understand. Now come to the mode 2 now. So mode 2, what is the explanation? So with the help of forced commutation circuit, we turn off the main SCR T1, and now the firing pulse is given to the T2. Now you see, firing pulse is given to the T2 now. So direction of the current start from Vs plus to inductor. From inductor, now the current is flowing through the T2, SCR2. SCR2 is on. From SCR2, the current flows through the center tapped point. You can see it from SCR2, current flows through center tapped point because already the capacitor is fully charged. So no current can flow through the capacitor. So current is flowing through the, in this way, current flows through the lower winding, and from lower winding to the common point, and from common point, here there is no connection. All of you, while drawing the circuit, you just draw your curve. There is no connection here. So mode 2, firing pulse is given to the SCR T2. When the supply is on, direction of the current start from Vs plus to the inductor, inductor to the SCR to T2, and from T2 to the lower winding, you can write L1, okay, or LW, lower winding to common point or center tapped point O, and from O to the back to the negative terminal. So current always flows to the negative terminal. You can see now the current is flowing in one direction in mode 1 and current is flowing in reverse direction in mode 2. So this is what we write in the mode 2. Again, during the due to mutual induction process, voltage induced across the lower winding induces with the secondary winding or links with the secondary winding. As a result, current flows through the flow. Okay. So what is a mode 2? Mode 2 T2 is on. Direction of the current start from Vs plus to inductor, inductor to T2, from T2 to the lower winding, from lower winding to the common point O to the V minus, source minus. Okay, Vs source. Now, during this process, due to mutual induction, voltage induced across the lower winding of center taper transformer links with the secondary winding. As a result, current flows through the secondary winding. So now you can see output voltage is always V0 equal to the source voltage. Now, in mode 2, what's happening actually? In mode 2, the capacitor starts to discharge. You can see the capacitor which is initially charged to the complete voltage, 2 Vs, it starts to discharge from its positive terminal. From Vc plus to upper winding, you can write a UW or U1, upper winding to the lower winding, L1 or LW, from lower winding to C minus. Okay, even this particular point we have to write separately. The capacitor starts to discharge under mode 2 from C plus to upper winding, UW, upper winding to common point to LW, lower winding to Vs minus. Okay, that is C minus, sorry, C minus. These two conditions. Now capacitor is starting to discharge. Remember this point here. So under mode 2, two things will happen. SCR T2 is on and capacitor is discharging its energy, and that energy has to come back to the negative terminal of the capacitor, C minus. I hope mode 1 and mode 2 is clear. Okay. So our ultimate aim is to generate the AC signal. Okay. Right. So here this is the same thing here, same circuit animation. Whatever. Now the current flows through the load. So now we complete the waveforms here. What are the waveforms we got? 2 Vs. Right. So parallel inverter waveforms will be different. So now observe, now gate terminal, yes, SCRT2 we are giving the firing pulse. Already mentioned to draw the firing pulse here. Now SCRT2 is on. When T2 is on, what's going to happen? Capacitor starts to discharge its stored energy. You can see capacitor will never discharge suddenly. It discharges or charges exponentially. You can see the capacitor voltage is discharging. As I've shown you in the circuit diagram, capacitor is releasing the stored energy and it reaches the constant value. Okay, discharges up to the minus 2 Vs. The capacitor has got the positive plate and negative plate. It charges up to plus 2 Vs and discharges up to minus 2 Vs. You can see capacitor discharging and discharging voltage will be minus 2 Vs. No need to explain regarding this voltage across T1. When the SCR is off, the voltage is blocked across the SCR. So no need to mention this one. We concentrate on IG1, IG2 and VC and follow the VS. And VS waveform will follow the VEC. Okay. So now you can see source voltage. Now you can see the source voltage exactly follows the capacitor voltage. What are the voltages available across the capacitor? It is available across the source voltage, that is the load voltage, V0 or Vs. Okay. Now, so capacitor discharges to minus 2 Vs and it remains constant for short period of time. So up to this point you remember, so mode 1 and mode 2. Now we continue here. Okay. So mode 2 everybody has understood, I hope, what we have discussed. Now let us move to the next stage, continuation of this one. So I'm just repeating what is actually the parallel inverter must contain the center tap transformer in order to improve the voltage. Without capacitor, we cannot apply the pulsated signal to the center tap transformer. As pure DC can never be applied to center tap transformer, pure DC with the help of switches is converted to the switchable DC or pulsated DC or in the form of a pulse signal, and that signal is applied to the transformer. Now we are going for the mode 3. Okay, so what is mode 1? Mode 1 is SCR1 is on, and mode 2 is SCR2 is on. Okay, and in mode 2 capacitor is discharging. So now we see what happens in mode 3. Okay, so now mode 3 starts again. In mode 3, yes, this is what we have seen in mode 2. So now we are discussing here mode 3. So what happens when capacitor is completely discharged? Any student? Whenever a capacitor is discharged completely, the capacitor recharges with opposite polarity. So mode 3, what is the first point? The capacitor which is discharged completely, it recharges with opposite polarity. Okay, as you have seen in the circuit. Initially it was upper plate is positive and lower plate is negative. Now you can see upper plate has become negative and lower plate has become positive. So I can show here. So if this is the previous circuit, what we have discussed, you can see the capacitor was charged to plus 2 Vs, upper plate positive. But now in mode 3, in mode 2 capacitor has discharged completely. Now the capacitor, yes, now the capacitor is discharged completely. Once a capacitor is discharged completely, it recharges with opposite polarity. So once again, the third circuit, you should draw this one. So in mode 3 also, SCR-T2 is turned on, and therefore the direction of the current flows in this manner. From where to where? Vs plus to inductor, inductor to SCR-T2, and from SCR-T2 to the lower winding to the common point to the Vs plus. So in mode 3 also, SCR-T2 is on, but the capacitor recharges with opposite polarity as shown in the figure. This is very important, minus and plus. So I confidently I can say any textbook you study, parallel inverter you will never understand. It is very difficult to understand without this animation. So those students who are listening, so listen carefully, all the 12 participants. Right. Now, capacitor is recharging with opposite polarity. That means it is storing the energy in opposite direction. Right. Now you see the waveform. So as I mentioned, once again, we have to generate the AC current, right? So in mode 3, what happens when SCR-T2 is on? Current is flowing in opposite direction. Capacitor is charging in opposite direction. Therefore, what is the current flowing through the load? Current flowing through the load is also in opposite direction. Okay. Now you can see initially we have seen that waveform. Capacitor, yes, it maintains the minus 2 Vs. Capacitor discharged and it recharges to the minus 2 Vs value, opposite polarity. Again, it has to start to discharge. I hope this is understood. And output voltage also equal to the capacitor voltage. But capacitor voltage will be twice, because across two windings, upper winding and lower winding it is placed, but output voltage will be equal to Vs. It will also increase in the opposite direction. I hope this graph is important. Okay. So I explain this one once again. So Ig1 in case 1 it is turned on mode 1. In mode 2 we turn on the T2. When T2 is on, capacitor starts to discharge. In mode 3 the capacitor recharges with opposite polarity. It maintains the constant. Okay. Now what we'll see what happens when our capacitor voltage is exactly equal to the output voltage. Now, yes, as I mentioned, minus 2 Vs. It recharges to the minus 2 Vs. Okay. So now you can see it is positive and negative. It is almost equal to the AC. Now we'll continue the explanation. So no need of this VT1 graph, only Ig1, Ig2 and 2 Vs, this capacitor voltage and V0, that is Vs, V0 equal to Vs. So today only this topic will take parallel inverter. Now you see mode 2. Now we are entering into the mode 3, what we have discussed. So in mode 3, as I mentioned, capacitor recharges. So first T2 was on. Now what we do, T2 will be off and firing pulse is given once again to the T1, and we'll see what's going to happen. Now the capacitor has to discharge. Now use. Now this is mode 4 for us. Okay, this is mode 4. So what is a mode 4? In mode 4, firing pulse is given to the T1 and T2 is off. So what is the direction of the current? Direction of the current starts from Vs plus inductor. Once again T1 will be on and current flows through the upper winding, from upper winding to the common point, center tapped point, and from center tapped point to the Vs minus. You can see in the animation. Yes. Examination also, current flow, current direction, you have to represent how the current is flowing. Okay. Now, what is the case mode 4? Class. మీకు లైవ్ లో చూపిస్తారు అస్సలు రాదు అస్సలు రాదు నేను కింద వచ్చి మీకు చూపిస్తాను రాదు yes let us take back. So in case mode 4, what is the mode 4 here? So mode 4 starts with turning off the SCR-T1. When SCR-T1 is on, the direction of the current starts from Vs plus to inductor, inductor to T1, and T1 to the upper winding to common point to the Vs minus. During this process, now the capacitor starts to discharge once again, as you can see. So we'll take this one forward. So mode 4, T1 is on. Okay. So direction of the current will represent. Okay, now what is the specialty in mode 4? The capacitor discharges once again. What is the discharging point? From C plus to lower winding to common point, and from common point to upper winding to the C minus. So now the capacitor discharging with opposite polarity. Current also flows through the load in opposite direction. So if you see the mode 1 and mode 4, direction of the current flowing through the load is in opposite direction. Okay. So this is the explanation, these 4 circuits. Now you can see capacitor, now what it has to do? It has to discharge. Examination, IG1, IG2, this capacitor voltage and Vs you are supposed to draw. Now you'll see in the next mode, just now what we have discussed, capacitor starts to discharge. Capacitor discharges from minus 2 Vc Vs to plus 2 Vs, and this process get continuous process. So this is the waveform we are supposed to show. I'll explain it. So as we obtain this waveform voltage across the capacitor, here also for load voltage also we do get the same. So we confirm that it is approximately equal to the square wave. So parallel inverter generates the square waveform signal. Okay. Yes, you can see that. So draw only IG1, IG2 capacitor voltage and voltage across the load. That finishes the explanation for the parallel inverter. So parallel inverter circuit, as you have seen, mode 1, mode 2, mode 3, 4 modes. Okay. Any doubt anybody is having, you can put forward. Next class we'll take the problems as well as the 3-phase inverter on different circuits. Okay. So same material is here. Whatever the modes we have discussed is this one, but I thought the animation will help you out, will help all the students to understand. Okay, 4 modes, be perfect here. Let me take the attendance screenshot. Only 13 students are present today. Any question anybody is having, you can. Okay, let me end the meeting today.